Hi. So this video will just be a description of a project I made while working in MIT this past summer. This project is an ion trap which suspends charged dust particles. The power for this trap comes in from a power outlet through this wire where my hand is right now, and it inputs into a microwave transformer which is inside this box. So the input is a standard 110 volt AC power, which has a frequency of 60 Hz. The transformer steps up the voltage to around 6,000 volts, according to the manufacturer's specifications. This high voltage is necessary to supply a large amount of power to the silver electrodes over here, which are the electrodes which actually trap the charged dust particles. And the high voltage is necessary because while the particles, if you look closely over here, while they seem very, very small, these particles still actually require a large amount of power to be able to be trapped against the force of gravity. So the trapping is best explained through an analogy to a saddle trap. So imagine you have a saddle on which you're trying to balance a ball. The shape of a conventional saddle has two opposite sides, which curve upwards, and the other two sides, which curve downwards. Naturally, even with a fair amount of precision, the ball will always fall off the saddle on one of the curved down sides due to the inability to put the ball in the absolute center of the trap, and the force of gravity pulling the ball downward off the saddle. However, now imagine if you started spinning the saddle quickly on a horizontal axis. The ball would still roll towards one of the downward curved sides, but while rolling off the saddle, if the saddle is spinning quickly, the saddle would turn so the upward curved edge would essentially replace where the downward curved edge was, and also where the ball was rolling. So now, the ball was trying to roll off the downward curved edge and it stopped since in the process of rolling there, the sides of the saddle switch, stopping the ball's descent. However, now the ball would simply just change directions and start rolling towards where the new downward curved edge is. However, since the sides of the saddle are constantly spinning, the upward curved edge would cycle around and move towards where the ball is now rolling, once again stopping the ball. So this repetition essentially continues, which creates the cycle of the ball being stopped continually when it's trying to leave the saddle. So this saddle trap is very similar to the trap created by these four electrodes right here. So imagine if there's a dust particle which is positively charged from losing some electrons from just rubbing off or something. So this particle, since it's positive, will be attracted to a negatively charged electrode. So what happens in this trap is that two opposite electrodes are charged, creating a negative charge in them. So this bottom electrode right here and the one diagonal to it. The two other electrodes are ground electrodes, which are this top one over here and the bottom back one over there. These essentially act as the opposite of the charged or discharged electrodes, which help move the particle back and forth. This will attract the positive particle towards them, similar to how the ball wants to go downwards. However, when it approaches the electrode discharges, making it more positive, repelling the charged particle from this electrode, similar to how the upward curved side of the saddle trap stopped the ball from falling off the trap. So this cycle is repeated at a frequency of 60 Hz, which is supplied by the microwave transformer. So simply stated, the particles in the middle try to move to whatever they're attracted to, which is switching so fast that whenever the particle tries to move towards what it's attracted to, it switches to a repulsion effect, and which essentially just keeps the particle moving back and forth between attraction and repulsion, keeping it trapped in the center of the trap. And so that's how basically what these four silver electrodes are for, and that's the theory behind the trapping of these particles. These two wires lead to copper rings on the outsides of them, and the copper rings essentially just trap the charged particles on a horizontal axis, so it doesn't leave the trap through the holes which are created in them. And so to build this entire trap, I use laser cut acrylic, and to make this entire box itself. The box itself took actually the longest time, since I had to make a few design changes to make it a bit safer by confining these wires in these two boxes and confining the transformer as a whole. So that took essentially the longest time to make. And so these four holes, which I guess you can see here. So there's four holes on the corners of the box, which are used to essentially ventilate the hot air created from the heat made from the transformer. And I'm currently trying to find a small fan, which I can either put in one of these holes or put right outside the box to try and cool the microwave transformer even more so it doesn't overheat, because it does heat up a lot, and heat would too much heat would actually end up breaking the transformer itself. And so I've also been so the charged particles themselves, I'm using something called lycopodium, which is essentially it comes in this little box. It's a plant spore, which is about 30 microns in diameter. And the reason I'm using this is because it's very uniform in diameter, as in each particle is almost identical to the one next to it and all the other ones around it. So it's very uniform, and there's not much variance in the shape and the size of the particles. And secondly, the particles themselves have a large surface area, which makes them easily charged when just rubbing on a surface or touching one of the electrodes. So it's very easily charged, which means when I turn this on and plug it in, it's very easy to get it to start going. All you have to do is simply pour a bit of the substance right there and kind of just wave it in right there. And I also use usually just a piece of like wrist paper, a thin piece of wrist paper to inside this to kind of like put a little bit more. And now you can see there's just a bunch of trapped particles in there, all of them relatively uniform in length and very clearly trapped, since there's like a laser pointer which illuminates them. So I've been running a couple experiments with these trapped particles, mainly by trying to find the resonant frequency of them. So the particles themselves should have a, in theory, without taking any other factors into them, just through the trap, it should have a resonant frequency of about 60 Hertz. But due to the air particles within the trap itself, there's a dampening effect which occurs on the particles. And the dampening affects the resonant frequency by essentially creating a range at which the particles inside the trap can resonate. And so I've been trying to find this resonant frequency range. So the dampening effect of it can be used to calculate the viscosity of air just using this trap. So that would be a cool kind of experiment and result to find, and see maybe how accurate this trap is in finding that. But so the issue is finding the resonant frequency range. And so I've tried two main methods in trying to find the resonant frequency. First, I tried using a frequency generator to apply essentially a 60 Hertz current to these two copper electrodes on the sides. And hopefully if I apply an extra charge to them, maybe that would help the particles resonate and possibly fly, essentially gain enough kinetic energy to get out of the trap. And in theory, what we would see is these particles which are trapped in here, when applying a resonant frequency to them, they would simply just fly out of the particle trap. So yeah, so my first method was attaching these wires to a frequency generator and seeing if I could somehow get them resonate electrically. And so this first method didn't work, and most likely the reason is because I couldn't get a lot of power into them because the highest voltage you can get from the frequency generators I had was 25 volts, and my hypothesis is that it's not powerful enough to make a significant effect in relation to the 6,000 volts which are being applied to the silver electrodes. And so the second method I used was to try and use sound waves to induce resonance. This method also did not work, even with fairly large speakers, and I tried using multiple different tone generators. And so the reason for this may be due to the acrylic itself, and which kind of provides a barrier between where the speaker is and where the actual trapped particles are, which would essentially dampen or lessen the effect of the sound on these particles themselves, and would not allow the pressure waves to go as powerfully through the acrylic, which would make it a minimal effect on the particles, maybe not allowing resonance to be powerful enough to make the particles leave the trap. And so those two methods didn't work, so I'm trying to research more ways in which I can hopefully get these particles to resonate at the current moment.